Hello, everyone. It's time to start. Can I please have you raising your hands on Zoom so I can check that you can hear me? Okay, so thank you so much. So we are here today to talk about improving supply chain performance via systems engineering V model. And I will introduce Suresh to you in a moment. But before that, I'll give you some updates about ASCI, the Australasian Supply Chain Institute. So if we can move to the next slide, and then I'll go back to introduce Suresh in a moment. So I am Flavio Macau. I'm the Vice President for Chapter WA. Glad to talk to you today. And I'll give you a quick update. We will discuss Suresh's presentation in a moment, and we will have some Q&As at the end. This webinar is recorded, and then it will be posted on the ASCI YouTube channel, so you can check on it later. This, of course, counts as a CPD point to you, and you can double check that on our ASCI events webpage to see what is next. So we are celebrating our public register going up to 30 registrants and counting and going up, which is really good. We are having increased participation on LinkedIn and MHD magazine. So thank you so much for helping build and strengthen our association. We are having a roundtable with executives on the 15th of June. So put that on your radar. And soon enough, we will have our ASCI 2021 conference, and grab your discounts, 50%, 20%, 10%, depends on where you are with ASCI. But don't lose that opportunity to be an early bird and to participate and to influence in the future of our profession. We have still time to submit to our ASCI awards, which is really interesting and good for our personal profiles, the profiles of our companies. And we will have a webinar pretty soon coming about the Fresh Connection simulation. If you don't know about it, it's a very well-regarded global simulation, and you can Google and you can get more information about our website, and we'll have something about it coming in the next weeks. And take your time to go and renew your APIS certification, or go for it if you need it. So it's coming soon. Our registration pathway, as you know, since last year we changed things a bit. So now you can be a registered associate, or you can apply to become a registered practitioner or a registered professional. Please go to the website, grab the information, and we are happy to help you to climb the steps and to show the world that you are definitely a very well experienced and competent supply chain professional with ASCI support. And moving up to the next, so this is just an example. Welcome to those that have already registered. So welcome to Scott Giffins, who get his registrations as a practitioner in operations. And then moving to the next one, because I want to give you as much time with Suresh as possible, go to the registration, click on the link, get your paperwork done and ready. It's not that complicated, and there's a self-evaluation tool that will help you check what you need to complete the points and to submit your application based on the work experience, on the certifications that you have, and any education that you have had in the past. Moving on, I can finally introduce you to Suresh. And Suresh is our star today, and only talking about his accomplishments would take about 40 minutes. I'll do my best to do it in 40 seconds. So he represented Shell Australia at global conferences. He is in the Australian Organization for Quality. He is a black belt, Lean Six Sigma. He knows a lot about quality, about engineering, about procurement, and about so many things on Lean Six Sigma. He's a lead auditor. So I'll leave you with Suresh, because he has a lot of interesting things to talk to us about the engineering V model and how we can apply that to improve our supply chains. So Suresh, and one more thing, if you have questions at any time, please bring them to the discussion board, type your questions, and at the end of the presentation, I will come back to the questions and answer them as quickly as we can. So thank you so much for coming. Suresh, it's up to you. Thank you. Oh, you have to unmute, Suresh. I believe you're muted, so if you can please unmute. There you go.
Yeah. Thanks, Flavio. Thank you so much for giving me this opportunity. I thank the ASCI team, especially David, Monique, for really pursuing me to deliver this presentation. And thank you so much for joining the session. Hopefully you'll learn a lot and go and apply it back to your workplace and gain value and provide value to your workplace. So the agenda for today's session will be about lessons learned, about a platform which came to ground, and that's the quality, it's a sort of a lessons learned. And then supplier technologies that will get an uplift post-COVID. What are our objectives from a supplier perspective? And what are the top supplier goals moving into 2021? V model, system engineering V model, how can everyone apply it from a project asset perspective, from a product perspective, or in your company? How do we make that change? How can you make a difference and add value to your company and your organization? Starting off with Alexander Keeland oil platform. On March 27, 1980, Alexander Keeland, an oil drilling rig, was stationed in Norwegian waters, and more than 120 workers were killed. During the capsizing, which stands as it was a fatigue cracking in one of the structural bracings of the ring. The crack was then traced to a 6mm fillet, which connected to a weld. And it was a profile of the weld and significant coal cracking that caused the issue. As you can imagine, a profiling of a weld can damage a huge structure. That is the service. So it is important that we as suppliers, contractors, or clients are aware that we are able to deliver service, a professional service, with the required quality, so it does not create any further impact in the future. So the supply technologies that will get an uplift post-COVID. Physical distancing has been the means. Robotics, automation, 3D, remote healthcare, remote education has been really in the upward trending over the last couple of years. And we see the trending moving forward into 2021 and beyond. As you can see, robotic burgers being delivered. Scuba diving kit used as ventilation. Robotic scanning. Robotic drones being used to deliver medicines and different modes and used in hospitals. So what are our main company objectives? Every company has an objective. It is compliance, to meet the company requirements, the standards, meet the regulations. Defect elimination, we don't want issues. To reduce defects, reduce failures, what are the issues? Improve financial performance. How can you improve financial performance? If everything is good, if you're meeting requirements, if we are eliminating, reducing defects, customer satisfaction, everything is good, then the financial performance shows its results. Increasing sales and the vision and the power of thinking beyond that. We want a long-term business in existence. How do we create that future and value for the company we work or the company we are owning? When you look at objectives, supplier objectives for 9001 2015, it talks about performance evaluation. One element is the compliance, the second element is the improvement element. On compliance, how do we make sure the assurance element, the control element, and then we have the improvement. As you know, the PDCA cycle calls for improvement. on getting those feedback and feeding that back into the cycle to create improvements. Today, we'll focus a lot on the improvements, how we can develop products and services that meet those requirements, applying those corrective and preventative actions. So what are our top supplier goals? If you look at from a supplier's perspective, prior to COVID, it was this: increasing supply chain, improving supply validation, reducing risk, improving compliance, improving relationships between suppliers. How do we improve that? Improving response time. So if you look at around 70 to 80% looks at compliance, performance, technologies, validations. 70% of the expectations was that. Beyond 2021, the goals are marginally changed. Let's come back. Number one is social responsibility, which talks about ethics, sustainability. How do we sustain? How do we bring the recycling or the renewable space? Ethics, reliability, supply reliability. COVID has created a big vacuum. And equipments are being manufactured and technologies in different places. We have services. But how do we bring everything within the country? Everyone wants to develop suddenly. So it's created a lot of vacuum. We are strong in services. Several countries are strong in equipments. How do you bring that technology together so every country can be self-sufficient? Supply chain disruption. The chain has been disrupted over the last 1.5 years. Projects which were completing on schedule have been delayed. How do we make sure that the supply chain is maintained and delivery, cost, and quality is maintained on products and services or projects and assets? So I will today now go into the system engineering V model. So it's important for the audience to understand clearly the concepts which we're going to drive here. One is Six Sigma. Six Sigma is a disciplined, statistical-based, data-driven approach and continuous improvement methodology. Talks about statistics, collecting the data. It follows the define, measure, analyze, improve, and control phase. Defining a problem. Measuring that problem in terms of data. What are the data available? Analyze the data, improve, apply improvements, and control. So this is a DMAIC, DMAIC. The next is lean practice. We're going to look at lean practice, seeking to maximize value to the customer, client, minimizing waste is lean. The final one we're looking here, how we combine those Six Sigma and lean elements into system engineering. And system engineering is an interdisciplinary field of engineering and engineering management that focuses on how design integrates with managed complex systems. How do we manage complex systems? So when you talk about managing complex systems, it could be projects or, it could be aircraft building, it could be shipbuilding, huge industries like FLNGs, they'll be talking about that multiple industries. And yeah, so now when we look at the system engineering V model, it's typically a V. You can see 4 phases. One is select. We start with the select concept. Coming down, we come down to the design phase. Then you execute the project. You execute the whole project and then go into operate phase. You hand it over to operations. So these are the 4 phases in a V model or any asset life cycle for that matter. So let us look at how we can look at the select phase. Select is you're going to select a concept. Could be, for example, in a power plant, you look at 2 turbines, or do you want to look at 1 turbine, or what type of turbine? It's a gas turbine or a steam turbine, or how do we get that optimization? That is the select phase. How do we improvise on the select phase? So it's a concept. You have a concept that you want to develop a power plant with this mega output, this rating to meet so many customers. This is the high level overview. Then it comes to the design phase. The design phase is so crucial that you define all the deliverables, the requirements, making sure that the contractor meets the requirements. So they deliver equipments and services for that project. It could be a turbine, it could be a pump, it could be a pipe, it could be structural for the whole project. So how do we meet that expectations? And that is classified. A system for a big project, for example, for a FLNG or FPSO or an aircraft or a shipbuilding or any process project, mining plant has a system. So then you go down the V curve, you look at decomposition, system classification, high level system, subsystem, and detailed design of equipments. And that is the design phase. Design is so crucial that if you get it wrong in the design, you will have problems for the rest of the 25 years, the life cycle of the asset. So as we move down the ladder, if you look at decomposition of the definition, if you down systems, subsystems, detailed design, and then you come down to installation, you execute, you install the equipments and make sure there's equipments. And going up the V chain on the right-hand side, you'll see unit testing. Each equipment will be tested and the subsystem will be tested. And finally, system verification. So verification against requirements, left versus right-hand side of the V. System verification plan, system verification. Finally, you come to system validation before you hand over on the top side, top right-hand side, in the corner, you see operate phase. In that phase, you make sure you build the whole power plant or LNG plant or whatever it is, a mining project, and you're going to deliver it to the operate, to the asset. At that phase, you do the system validation. Is the system right? Is it delivering right outputs? Are we looking 8 million tons of LNG? Now, what is the output? Are we delivering that expectation? What do we need to validate the system? So that is validation. And then we hand it over to assets. So that is the crucial phase of system engineering model. So how do we look at improving in each phase of this? Select phase, what are the elements? And design phase, what are the elements? Executive phase and operate phase. So as I said, it's all about defining. Initially, you'll have stakeholder discussion during the concept phase. You decide the concept, then system requirements, subsystem requirements, and unit and competence, basically units, and then development, and then it's verification, validation, system integration. So on top side, you can see it's a concept, and then it moves into design. And from design, it moves into development and production. And finally, you hand over the system when the validation is good and the systems are good, and then you hand over to operations. So where are the opportunities in this? So the opportunities in this are in the select phase, right? You look at the first select phase. So what are the opportunities here is mainly competitive scoping, fit for purpose scoping. So you look at, for example, using 2 turbines or 2 generators or 2 motors. So what will give the maximum output? How do we make sure that the specification, the requirements are right to get the perfect scoping so it's not overscoped, it's not overpriced? At the same time, meeting our expectations of delivery. So that is competitive scoping, and that phase comes during the select concept phase. If a lot of people will be working on either a product, a project, or within your company, so I think it's important to look at which phase you're working in. You may be working in one of these 4 phases, definitely, in some stage of the other. Then moving into define phase. Define phase, you start developing all the specifications for systems, the requirements, the contract requirements, and making sure it delivers the wider objectives. So how do we get these project specifications and compile it and make sure it's the right specification? It's not too overly specified or too less. And have we done a risk analysis? Have we done a pestle analysis of the specification? What are the changes in terms of supply chain transformation? What is happening? How do we apply those? Similarly, it is a phase, design is a crucial phase where you can introduce digitization into the whole process. For example, a pump which is working of its own, how do we digitize that particular pump? Possibly we can set a pressure transmitter or a vibration meter directly onto the pump to pick up those signals. And that should be done in the define phase because that sets the asset for the lifetime of the cycle. And then moving into the execute phase, what are the areas? It's efficient execution, supply chain transformation. How do we execute efficiently in delivering those projects? Putting those structural in piping, electrical, instrumentation. How do we deliver efficiently and make sure that the transformation, getting the right product, right quality product from suppliers and able to deliver that in the execute phase. And finally, into operate phase, how can we introduce digitization? And from a production maintenance perspective, we have the CMMS, workflows, asset management, reliabilities. So there are a lot of areas you can really look at improving by working into what are the top key issues in each of these phases and checking up with your management on what areas you can improve and working on those. So what are the cost escalation findings? Cost escalation findings globally has shown that the specifications are too, like oil and gas and everything, they have got very high specifications. It's and in terms of requirements, the requirements are also high because you have quality, HSC, environmental, project, engineering, scope of work. So all the scope of work, is it the right scope? Have we defined the right scope? And then the cost of quality. A lot of failures have started happening on the projects, on multiple projects, mining or oil and gas, or a lot of people from here are from logistics, okay, logistics and supply chain, and also defense industry, right? So what in logistics is an issue, truck transportation, maintenance time, how can we optimize, right? Supply chain, you can look at delivery cost and reliability. How can the supplier meet those delivery objectives from a quality cost perspective? And from a defense, the whole V model applies in terms of defense projects. If you're building a submarine, if you're building an aircraft, the whole thing of V model applies in terms of concept, define, execute, and operations. So this is exactly what it is. So how do we start with the concept select, and then we have the requirements, and the requirements are all these requirements. It could be contractual requirements, process safety, it could be personal safety, environmental, health, security, operability, maintainability, availability, expandability, and constructability, decommissioning. So how do we get these requirements in such a way that we're able to select the best requirements and meet that? So for that, if you look at the orange box, I mean, you're not able to see it, but you capture the needs of the relevant parties, the stakeholders. And then the purple boxes are on requirements. And then finally, you get the solutions. What are the needs of the expected parties? How do we condense it and eliminate the unnecessary specifications and meet the exact requirements? And then do a cost, risk, and value trade-off to make sure the whole trade-off is right. And that is the circle you're seeing in each of the system 1, system 2. And then you do the verification and validation to make sure this requirements is the right requirement. And that way you do the define phase, select phase. As you can see, for each equipment on the right-hand side, it could be a pressure vessel, it could be a pump, it could be a motor. All these equipments will need to undergo this level of discussion to make sure our contracts are right, our requirements are right, and in terms of quality, in terms of safety, performance, cost, and delivery. And this is the types of requirements and how the process safety, health, security, all these requirements are defined in the contract. What are the interfaces between these particular disciplines? And how do we maintain the human physical strain? What are the performance activities? And in terms of design and startup, how do we make sure there's a right integration between these? And also the brownfield constraints and how a system could be designed and built and documented. These are the initial applications based on optimization of specifications. We will be able to look at reducing 60% of engineering and procurement hours, time of concept to ready, concept start to ready was reduced from 9 months to 24 months for multiple projects. So if you're able to condense those requirements and able to meet the expectations of the stakeholders, it's a wonderful example. You can reduce drastically in terms of the cost and the schedule expectations. And then we have the project specification, contractor requirements, cost of quality can be reduced as well considerably. And we talked about digitization, and digitization, how it can be introduced in the define phase. There are multiple things happening. As you can see, big data, autonomous robots, simulations, the industrial Internet of Things, cybersecurity, cloud. So all these elements, so how do we pick up those signals from that individual equipment, the motor or the pumps or the turbines or the generators? Are we picking up the right signal? Is it analog or a digital signal? And how do we convert them in terms of analyzing the flow meters, vibration meters? So how can we revolutionize the digitization? And that phase, transmitting those signals, is an analog signal, is a digital signal, and then the monitoring the whole signals. Can we manually monitor? Is it digitally monitoring? Are we going to do AI monitoring? Or are we going to do big data? For example, on maintenance systems, we can use the big data approach, where the data plays a big part in terms of existing issues, and then we're able to clarify that with CMMS. It's a transition from CMMS, where the big data becomes crucial, and applying back that into the cycle. And also, if you look at oil and gas, IOGP and JIP 33, they have standardized a lot on specification, because if you look at oil and gas companies like Chevron, Shell, or Woodside, and so they were all having different specifications. They standardized it into one, so it's a compact one. For example, a wellhead or a pump, they have got a specification, a standard specification giving an output of so much. So everyone from Woodside or Shell, or they pick up from IOGP now, and they standardize the specifications, so it's easy. For example, subsea pipelines. What are the specifications? So from an oil and gas perspective, they formed a board, IOGP, and the JIP 33 is one of the key ingredients. So if you go and search into JIP 33, they have got specification for motors, pumps, and you can pull off that and then template it to your requirements. So it's a wonderful opportunity for you to standardize within your industry as well. So we covered both the define phase and the concept select phase. This is an execute phase. Some of the projects which came up from the asset phase was some of the issues was on leaks. This is a personal example which I applied Lean Six Sigma, and we're talking about the define, measure, analyze, improve, and control phase, and how we establish that for a skid. A skid is a HPU skid, for example, a hydraulic power unit skid, which is used to provide hydraulic power initiation for a turbine shaft. Initially, it has to be lifted up to 3,000 psi or 10,000 psi, depending on the turbine, and this unit supplies that hydraulic power to lift that shaft turbine. Now, this unit was supplied to multiple locations across the world to run the GE turbines, right? So, and GE turbines, and we had multiple issues. And the issues and the cost of failure for these was, the top failures were leaks, vibrations, and design. So I picked up this project on from GE, and I did it personally. And basically, we took 1.5 years to finish. So we defined the problem. We took all the in the issues, top 5 or 10 issues for the skids, and we were able to define and measure it, and when eliminated it in terms of leaks, vibrations, and noise that is greater than 85 dB was not sustainable. So then we took each of those problems and analyzing the issues. Leaks, why is it leaking? Fitting leaks, incorrect fitting, change the suppliers, or what are the techniques? What has gone wrong with the fitting? What is the competency required? Are we tightening or bolt tightening it perfectly in terms of the fittings? Are we doing the right process and procedures? Similarly, vibrations. So vibrations had multiple issues like oil change, not using the right oil, right lubricant, or the correct time, the frequency, the piping schedule, and alignment of the pump and motor, and design from installation perspective. We changed the design insulation material to so as to reduce the insulation, the sound, the dB, which we get outside the unit. So we increased the thickness of that. We changed a design and added some more insulation to reduce the impact of noise and hence reduce the voice. So, and that was in the analyze phase. And then finally in the improve, we applied these back into the cycle and put it on to different operating units. And we looked at results and we were able to reduce the impact. And finally, after nearly 1 year, we achieved a Six Sigma, 99% success, which means that we eliminated the leaks, vibrations, and the insulation and the noise issues within the project. So this is a very good example for you to outline how in each phase you can really take a project and make a change and add value to your business wherever you are. This is another project I did within the drilling space within Shell. So we had, so the cost of failure in drilling is hovering around 20%. 20% of, is around $5 to $10 million in a drilling campaign for 6 months. So I took a target initially for Prelude was we drilled 7 wells, and my initial target was 3 to 4%. And how we applied that was, we got the failures, all the failures we noted on the drilling process. 1 day loss of cost of failure for a drilling rig not to drill is $500,000. So when you calculate that, if your equipment doesn't work for 1 day, you're losing $500,000. So based on that, we identified all the failures which happened across the cycle of the company and externally as well. And we were able to analyze the top 5 or 10 and then reduce the cost of failures. And we were able to bring it down to, I did it in Shell was maybe 1 or 2% approximately. And then for the latest well we drilled, we got an NPT which is less than 0.7. We targeted 2%, but we got less than that. So it's important for everybody to have a target or a goal and how much you want to reduce. So it's important for us to, if you have to make a change, you have to create difference and bring value to wherever you are. And if that is the case, you got to take targets and take challenge and do it. Yes, you may not get it to that extent, but at least even 50%, getting it to say 30 or 50%, you have brought value to your organization, to yourself, and how you can make a difference. And this is asset phase maintenance and digitization, how AI and big data plays a big role. And as you can see, the asset phase, there is predictive maintenance, preventative maintenance, and reactive maintenance. Now, most of the people are either in the preventative or reactive phase. So when an incident, when, for example, a pump fails, then they start looking at, oh, we need to call the pump manufacturer, we need to fix it. So people are in the reactive phase. So how do we convert them into the predictive phase? Predictive phase is looking at pump running, vibration analysis, noise analysis. Based on analysis, they do a predictive calculations. There's a algorithm, and basically it gives you a predictive failure analysis. So based on that, you estimate your failures. So I think a lot of people are moving into the predictive phase, and that's how it is. Here you can see an example on the right hand side how a pump was removed offline, and AI and some of the predictive analysis is picked up by AI. Artificial intelligence, and then it reacts on your system, and so you're able to predict that failure and accordingly remove the pump offline and do the work and then reinstate it. So there's no loss of time. So that way you can bring the backup system into place and then get the work done and then reinstate the system which has got problem. So it's a wonderful opportunity for everyone to really look at how you can implement it in your workplace. So looking at other sectors like financial, aerospace, healthcare industries, or municipal services. For example, financial services, what can you improve? Loan applications, the timing of the loan, how long it takes. It takes 1 month. Okay, why is it taking 1 month? Where's the breakup? You can do a lot of improvements on that. Banking institutions, phone calls, customer service, aerospace industries, the maintenance, and configuration management. Health saver industries. Health industry is quite a big industry now, and you can see that a lot of things you can improve there as well. So I'll go into specifically into logistics, supply chain, and defense industry, which a lot of you from the audience are right now. So from a logistic perspective, what can you do? So you have trucks, you have transportation, you have delivery. So how do we optimize the movement of the trucks? So how do we create the Kaizen, the lean elimination? Waste comes hugely. What are the top 10 issues in your logistics? Yeah, take those top 10 issues from your management. Go and take it and take those challenges and try to apply the principles of DMAIC or the lean or system engineering concepts and make a change. So it's important. There are so many things in trucks. With trucks, it could be shipping. Okay, what is logistics? How can it, from a shipping perspective, from an aircraft perspective, how do we do that? And supply chain. Some of you are working in supply chain. So how can we increase the delivery? How are we getting the right product? Is it the right quality? From a cost perspective, from a reliability perspective, how can we make sure a product is able to last longer within the customer? So I think giving that expectation and setting that expectation from a defense industry, the whole V model applies. You can really apply it across the select, the define, the execute, and the operate phase. So looking at the agenda, we covered clearly the lessons learned. We covered the supply technologies that will get a lift post-COVID, and what are our objectives, top company objectives. As you can see from those objectives, that it is clearly about creating value. It is creating value in terms of cost, quality, safety, reliability, and you can see now the social attachment has come in terms of ethics, and also in terms of renewables and recycling industry. How do we bring that component back into automation? How do we bring automation into your workplace? And those technologies that will get post-lift. So how do we bring that change in your existing systems, and how can you contribute to that? And supplier objectives and top supply goals. So what are our goals? We model, and across any industry or any type of work, you can do a lot of improvements. And I can challenge that. If you have the mind, you can do it. And that is what it is. It is, you can, if you think that you can, your company improve, go to your management, ask them what are the top supply issues. Go to the management review and ask them what are the issues. Take those issues, take those challenges. We need people to take challenges so we can make a drastic change and transformation across the industry, and we can grow, and professionally as well as personally. And that is what it is. So I mentioned about improvements, and you can really make a lot of improvements across all the phases. And I also gave you typical examples of the audience as well, the specific areas where they're working. So yeah, so I'm so happy that I'm able to deliver this today. Hopefully, you will take those challenges. Go to your management today. Ask them what are the things that will make a difference. Ask them what are the top issues and how you can bring value to them, how you can make the difference. And hopefully you learn from this and go and apply. Go and apply. Thanks. Thank you.
Okay, thank you so much, Suresh. This was a very informative session. Lots of food for thought there. Now we are open to questions. You can bring your question to the chat or to the Q&A. I'm monitoring both. Some of my questions, you just answered them. So I was going to ask you, where do you start? And you just told us, go to your management, look for a project where you can implement those activities. Also, I was about to ask you, which sectors are actually implementing those kinds of activities? And you just came up with some examples. And just to instigate people to participate in the chat, I just put there a link about an example from Australia Post and how they are implementing digitization through a digital twin of their supply chain or of their distribution system, which is very, very interesting. So as we wait for questions from our chat and our Q&A, I have one here that's kind of a new question in many ways, because you are such an expert in quality assurance. And I would say that we as supply chain procurement practitioners, we know quite well how to measure quantities for real products, those products that we can touch, that we can see, that we can smell. And now we are moving to procuring companies that will service us with artificial intelligence, with information flow, with space on the cloud. How can we measure quality for those new things, those new suppliers that actually we are not used to because it's so new for us?
Yeah, it's a good question, Flavia. So yeah, I understand the challenges for any new industry because the AI, the cloud computing, as you can see, how the development of big data is taking place. And that is where the transformation into 4.0 is taking place globally. And so what it really means from a quality or a project 4.0, it really means the transition. And basically, from an Australian perspective, it has not really transitioned. From a global perspective, I've been trying to bring the 4.0 speakers back into Australia. It's taken around 18% of the global manufacturing companies are now into the 4.0 space. What it really means is the transition into the big data, the Internet of Things. How do we measure it and map it? Because people are in core skills like a mechanical, electrical, yeah, into supply chain. But how do we bring those elements? So it brings about that slow transformation in terms of learning that data management, and a bit of, I mean, everybody can't really be a master. But again, a lot of the people are employing like data technicians and digital experts to make the transition or create programs for them. And that also brings a new supply base. So a training on quality 4.0 is crucial at this moment, and how we transition. I'd see more focusing on the manufacturing industries like US, and a lot of the India, China, and also, but in Australia, it's more service oriented, and manufacturing industries are more in the Melbourne and Sydney space. But if you look at that, how do we bring the quality 4.0 or project 4.0 is crucial. So either the management has to be forward thinking, has to get those trainings and familiarize, alternately engage competent people to support them achieve their wider objectives. Thanks.
That's great. That's great. Thank you so much for your answer. And we have questions here in the Q&A session. I'll start with Vijay Umapathy, and Vijay is asking, "Hey Suresh, can you please cite an example from your industry or company where the scope of the project was done with reference to the V model from the supply chain perspective for cost improvements based on EOQ or MOQ or packaging unit of measure? Please advise if the question is understood."
Yeah, so I think from a supplier perspective for a packaging unit, yeah, so again, packaging is now considerably changing, right, in terms of plastics and how we are going to use renewable space. So that is one element how you can look at it. Second element is technology. Packaging is so how do we apply technology? Is it a manual equipment or from a technology perspective? And so the expectations of that, I think those are the two areas we can focus on. I'm not specifically into packaging, but in terms of supplier quality delivery, are we delivering the right quality requirements? The quality of that, the delivery and the quickness which comes with technology, and also how do we bring the automation component into it? So it's important to look at those four elements. So I would say that Vijay. So basically, yeah, from my perspective, specifically, I'm not worked in the packaging industry, but from a supplier perspective, yes, you can do a lot of things. The suppliers are the key. The suppliers know the job. They can produce a motor. They know the motor very well. So they can make a motor which is really good or really bad as well. So they know the ingredients of how they can deliver well and how they can bring automation. So it is that looking beyond the box, and how do we bring the automation element and considering the top supplier goals now, how do we link that up, that particular product into that top supply goals? As you can see, the supply goals beyond 21. So how do you make the transition to go into that space? So we need to look at that and then transition. It's a 4.0, or how do we get the right resource if you have the funding to make the transition happen? So I think those are the things you can work.
Good, good. Thank you so much. Now I'm moving to Cosma Nicolau. And Cosmo is asking, did you ever experience any issues with having AI data results not accepted by operations, even though they were part of the initial process? If so, how did you then handle and react to that?
Oh, that's a pretty good question. Is so if you look at all operations, right? So if you look at CMMS, what they have now, we are having issues in terms of data capture. So all the companies which are there right now, do you think they're doing everything perfectly in terms of whatever failure happened, and are they doing the root cause? They've done it perfectly, and it's so like crystal clear. It is not. So that's the real world we are in. The CMMS, which they have done all, is sort of a manual entry in the SAP system. But a lot of the root causes in a lot of the key companies, there's no root cause, there's no real corrective action or preventative action. So when you're using the new technologies like data science, or how do we link this up, because the data science will pick up only data which are existingly good, or whatever you're given before. So when a data science goes back into the CMMS data or the maintenance data, you don't have a good data, then basically the data science will only do what it can do. But what you can do is looking forward from now, how you can apply those elements and create a better data and have a systematic approach. And I think that is what we need to focus. We can't go behind so many years to see what they have done. Maybe some companies have done very well in that space, but it's going to be a challenge. So moving forward is what we need to look at beyond 2020, 21, and how we can apply the data elements or IoTs, or the concepts of digitization into play.
Oh yeah, and I can totally see how moving forward can be difficult to many people, and how they will not accept the data in the beginning. So yeah, it's all about bringing them the results and showing them that you can improve the system based on that. So really good. We now have a question from Guy Ferrier. There's a lot of emphasis on agile at the moment. Can the V model be used in a Scrum or Kanban sense using 2 or 4 week sprints?
Yeah, I think yes, it can be. Yeah, there's a lot of focus on agile, because agile is also sort of, it's a continuous improvement process, right? So all these things are in terms of applying those PDCA process: plan, do, check, and act. So that's the cycle. So how we get this cycle and the process is through agile, or the different processes. It could be Lean Six Sigma, or it could be whatever tool you're using. Concept and the principles are the same. If your fundamentals are strong, you will succeed. But how they picturize it, or specific areas may be slightly different. But the concept and principles are what we need to focus, and then automatically the tools will fall into place. Yeah, so that's my recommendation.
Okay, all good. So yeah, there is room to use it in those short sprints. And now we are back to Vijay for an extension on his question. And then translating data from the quality perspective, I guess these days we want to visualize the data. So how do you transfer and handle the data to an IoT perspective?
Yeah, so I think so I should be very frank here. I'm not a specialist in the IoT and AI space. I'm also learning, like you, each of you. So let's be clear on that. So I'm a mechanical engineer by profession, and I know a little bit of internet and quality 4.0, but I'm not a specialist. So I think we need to ask this particular question to a digital specialist on how do we convert it into IoT, the existing data. And that is for the digital people to answer that. Thanks.
And I would add to that that most of the times you may be, procuring someone that will provide you with services in IoT on the cloud and things like that. So
Sure.
that's a very good question to ask during your procurement process. So you are servicing me starting this July. So how are you handling this data? And you can bring a bunch of questions about safety and cybersecurity and availability and who has access to what. So we could probably have another workshop, another conversation on all the questions that you must ask from your supplier as you move to this digital space. So really, really good question, Vijay. Okay, I can't see any other questions at this moment. So Suresh, any other questions or any other points that you would like to bring up to close our conversation today?
Oh no, it has been really good. Good to discuss with the team and with all the audience. So very good questions. And yeah, hopefully they have learned a lot from today, and they are really passionate and motivated to make a change in the workplace and go and develop and look at things differently. So my suggestion is to take the problem. Don't be afraid of a problem, and take a challenge. Take a couple of challenges. So then you can make a difference, and your company or the organization will definitely appreciate your initiative. I know everybody is busy, right? We're in a busy world, but you've got to make that extra time to take that little bit and make a difference. So I urge all of you to do that.
Fantastic, fantastic. Suresh, thank you so much again for your time today. I feel very privileged to hear from you and to learn from your wisdom and experience. If we don't have any other burning questions, just a friendly reminder that this presentation, this workshop was recorded and it is available to ASCI members. And if you have any other questions about the following events and accreditation, please come to social media, engage with us. Monique is always there watching over us and helping us in every moment, every time. And if we don't have any other burning issues or questions, I would like to thank you again for coming today and hope to see you soon in the next event.
Yeah,
So thank you.
thank you.
Thank you so
Thanks.
much.
Thank you.